Welcome to the 3D printed classroom. In this video we're going to be talking about how you can use your 3D printer to help teach about energy and matter. So first up is this. This is an example of how you can use mechanical energy to create electrical energy. And so the designer of this actually, I think he wanted to test out two things. One are these gears that somebody else designed, and the other is a belt like this. I bought a rubber one, a 400mm rubber one off of Amazon, but he had a file for one to print in TPU, which is a really flexible filament. And so in theory you could print most of this, everything except for the DC motor. So the idea behind it is that you crank this wheel and it spins the direct current motor, which changes it from a motor into a generator. Now the idea behind it was that it would power an LED, and the designer said that he was able to produce enough light to use it as like a little flashlight in a dark room. I have not been so lucky. The motors that I've bought are not producing even 1 volt of electricity, and you need between, I think 1.7 for like a red LED and 3 volts for like a blue LED. And I haven't been able to light up any light bulbs so far, but I'm still working on it. However, I've used this to teach how energy is created by using my multimeter, and if you don't have one of these, well, you should get one. But it works pretty. You ruined it.
Sorry.
Alright, thank you. I haven't been able to get it to light up a battery, but by using a multimeter, I can still demonstrate to my students that it is producing electricity. So if I put the two probes on the leads, and I crank away at this, I can show that I can produce about 0.2324 volts of electricity. Now that's 0.2, which, like I said before, isn't nearly enough to light up an LED. So I'm still working on this. I'm going to tweak it, and if I can find a better DC motor that's going to produce enough electricity, I'll update this video. Next up is this windmill, and so I'm using the same motor. So this windmill also isn't producing enough electricity to light up this light, but it's still, you can still demonstrate how it produces electricity. And if you have a fan, you can hook it up, and it will spin the blades of this, and it will turn that DC crank. And so being able to see up close how wind energy is converted into electric energy is pretty fun to do, and it's a fun thing for them to see. I desperately want to figure out a way to get a DC motor in this that will light a bulb. The design of this is pretty great because you do have a hole in the bottom, and then the stand, it is hollow, so you can wire it. And I printed 2 of these LED stands from the mechanical energy design, and my thought was I could just have the light bulb right there so that students can see it light up as it spins. I think it's a fantastic design, but again, my motor situation is really leaving a lot to be desired. Next up, this is sort of a design of my own. It's a bit of a remix of somebody else's design. I found this street light, which was designed by a model maker, I guess maybe for like garden scale trains. And so he had it wired up and with an LED light, and I thought, well, I know for a fact that I can get a solar panel that can produce enough volts to light up a light. And so I combined his design, and I made a stand for it that'll hold my solar panel. And this is the most satisfying out of all of them because, one, it produces light. You can't see it here, but it is lighting up that LED, and so at least I don't have to tell the kids to use their imaginations. Finally, we have this. This is a cross section of an engine that I found on Thingiverse. And I absolutely love this because of the multiple moving parts in it. So you can show how the explosion in a cylinder forces it down, and it just keeps going around and around. So that, the novelty of this is just too great. I love it. But in addition to that, these valves actually work. So I printed them in kind of a golden PLA, but if you get like some PET G, they'll probably be a little bit more flexible and a little kind of less sticky. But so you can demonstrate how the gasoline flows into the first valve, it's compressed, it explodes, and then it is sent out of the second valve as exhaust. And the engine is pretty awesome because it combines different types of energy. You have the stored energy of gasoline, you have the electrical energy which creates the spark, and then you have the heat energy which forces that the cylinder down. And then you're creating mechanical energy. So it is a combination of many different types of energy all working together to help move your car along. So there you have it. Here are 4 examples how you can use 3D printing to teach about energy in your classroom. I'll have the links to all of these files in the description. If you want to check out my other videos, I have one about math manipulatives in your classroom. And thank you so much for watching.
You're welcome.
All right. Toodaloo.
Toodaloo.